The combined gas law is real simple. I'm sure a lot of you have been thinking so far, well, okay, that's great, Mr. Siegel, that you've changed pressure and volume, and you've changed volume and temperature, you've changed pressure and temperature, but what happens if you can't hold that other thing constant? Well, that's where you get the combined gas law. So you'll see that the combined gas law is basically a combination of all three things together. So you've got P1 times V1 over T1 equals P2 times V2 over T2. The only thing that you're going to be held constant is your amount of the gas. So in other words, moles. So how much gas is there? You're in a nice sealed container, so that's never going to change. Again, temperature is in kelvins. Don't forget that. That's the only one that really is important that you keep the units. Temperature must be in kelvins. I cannot say that enough. So let's do some examples. It's the easiest way to understand the combined gas law. So you have a sample of gas in a flask with a volume of 350 milliliters at 25.5 degrees Celsius. The pressure of the gas is 135 millimeters of mercury. If you decrease the temperature to 0 degrees Celsius and the volume to 275, what is the gas pressure at the lower conditions? Now, it's always we could always make a guess as to what's happening, like, oh, the pressure went up, so we can guess the volume went down. But the problem is because we have both pressures and volumes changing, and temperature's changing, we have no idea how it's going to actually turn out in the end. So let's write our formula and plug in all of our numbers. So P1 V1 over T1 equals P2 V2 over T2. My pressure when I start is 135 millimeters of mercury. I do not need to convert it into ATMs. I can use it. It asks what is the pressure, so that's what I'm going to be looking for. V1 is 350 milliliters. V2 is going to be 275. T1 is 25.5 plus 273, which is 298.5 Kelvin. And T2 is 0 plus 273 is very obviously 273. Okay, plug everything into your formula. 135 times V1, which is 350, divided by T1, which is 298.5, equals P2, which is what I'm solving for, times V2, 275, and T2, which is 273. Now, like I said, pressure, volume went down, so I would expect my pressure to go up, but temperature also went down, and because temperature went down too, there's no clear way to identify what's going to happen to the pressure. So I'm going to cross multiply, and I'm going to solve for P2. Get rid of my previous calculations. So I type in 135 times 350 times 273, because I'm cross multiplying, divided by this, where parentheses are my friend, 298.5 times 275. Hit enter, and I get 157.1 millimeters of mercury. But I've got to keep to the correct number of significant figures. So I look at my numbers. I've got 3 sig figs here, 4, 3, 3, but only 2 sig figs for that volume. So I have to convert this to 160 millimeters of mercury. Sig figs, extremely important in these problems. Okay, let's do one more example. A certain mass of calcium carbide reacts completely with water to give 64.5 liters of C2H2 at 50 degrees Celsius and a pressure of 1 atmosphere. If the same mass of calcium carbide reacts completely at 400 degrees Celsius and pressure of 2 atmospheres, what volume of C2H2 will be collected at the higher temperature? Same principle. Pause the video, solve it yourself, come back, see how I solved it, and then we'll move on. Okay, write your formula. P1 V1 over T1 equals P2 V2 over T2. Pressure is 1 atmosphere. doubled to 2 atmospheres. My volume when I start is 64.5 liters, which is quite large. I'm looking for the new volume because it says what volume? T1 is 50 plus 273. I like to use 50 a lot. There's 323 kelvins. T2 is 400, which is a considerable temperature change. So we get 673. Plug it into your formula. 1.00 times 64.5 divided by 323. 2 times V2 divided by 673. Grab my calculator. 1.00 times 64.5 times 673. It's going to be a gigantic number, which it is, divided by 323 times 2, close my parentheses, enter, and I get 67.1 or 67.2 as my volume. 2 liters. I double check my significant figures. I've got 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs, and 3 sig figs. So guess what? We're going to use 3 sig figs for my answer. So I get 67.2 liters is my final answer.